Okay, here we are doing level 3 formula writing, and just make sure that you've mastered level 1 and level 2 before moving on to this level at level 3. And the main concentration on level 3 is about taking the polyatomic ions that we already know and then adjusting them to make new polyatomic ions. One way that we're going to adjust them is by adding or subtracting oxygens, okay? And the other thing is by just adding hydrogen. So those are going to be the two things that we're going to talk about here in level 3. Okay, so let's talk about what happens when you add an oxygen to a polyatomic ion, the ones that we've memorized. Okay, and if we look here, if we add an oxygen to an ATE polyatomic ion, what you're going to do is you're going to add the prefix per to it. For example, if we have chlorate, that is ClO3, that's one that we've memorized. If we add an oxygen, okay, to ClO4, it's no longer chlorate, but we're going to call it perchlorate. One thing that you want to know is that the charge is going to stay the same. So no matter how many times I add or subtract the oxygens, not the hydrogens, but the oxygens, the charge will stay the same. But we're going to be changing the prefixes and maybe some of the suffixes for these polyatomic ions. So when you add, you're going to just add the prefix per. Everything else stays the same. You add your oxygen, the charge stays the same. It just changes from chlorate to perchlorate. Now what happens when we start subtracting oxygens, okay? Subtracting oxygens, we are actually going to mess with the suffix, okay? So when we subtract one oxygen, okay, the ending is going to change from an ATE to an ITE, okay? Once again, the charge stays the same. So when you're adding or subtracting oxygens, charge stays the same. We're just changing the suffix here from ate to ite when we subtract one oxygen. So if nitrate is NO3, that's the one that we memorized. Well, if we take an oxygen off to make it NO2, where the charge stays the same, we change the ending from nitrate to nitrite. Now, what if we wanted to subtract two oxygens, okay? Well, going from nitrate to nitrite would be one oxygen. What happens if we take away two, okay? According to the directions here, if we take away two from the polyatomic ion that we memorized, because all the ones that we memorized are the ATE ones, okay? We're actually going to do two things, okay? The first oxygen that we subtracted is going to change this to ite, okay? But the second oxygen that we're going to take away, we're going to add the prefix hypo, okay? So that ATE polyatomic ion is going to change to ite for the first oxygen, and then for the second oxygen, we're adding that prefix hypo, okay? For example, if we had chlorate, which is ClO3, if we subtract one oxygen, it becomes chlorite. But if we subtract two oxygens, it's going to become hypochlorite. Okay, and that's kind of like everything that we need to know for the oxygens. And I got this little thing here at the bottom, like putting it all together. And this just shows that this is the one that we're going to memorize. Okay, so we call that the given. And that's the ATE polyatomic ion. If we add an oxygen, we just change it to per ATE. If we subtract an oxygen, we change it to ITE. And if we subtract two oxygens, we're going to call it hypo-ITE. Okay? And then there's this little note here, this little asterisk at the bottom that's going to talk about halogens. Okay? Now, when we have halogens, which is group 17 on the periodic table, these are the halogens. We can actually substitute that chlorine for fluorine, bromine, or iodine, and all the formulas stay the same, okay? So if this is chlorate, ClO3, we also have fluorate and bromate and iodate, okay, that all have three oxygens. If you go up one oxygen, we get perchlorate, perfluorate, perbromate, and periodate. If we go down an oxygen, all these ATEs change to ITEs, so we have chlorite, fluorite, bromite, and iodite. And lastly, if we take away two oxygens, we not only get the ITE, but now we get the hypo-ITE. So we got hypochlorite, hypofluorite, hypobromite, and hypoiodite. And we're going to use this information to do a couple practice problems here on the back side, okay? So our first problem is going to be calcium perchlorate. Now all our formula writing stuff is still exactly the same, okay? We got to look up the charges, and that's actually the hardest part, okay? So we're going to look up the calcium, and we're going to look up the perchlorate. Calcium's pretty easy. It's in the +2 column. So we're going to write down calcium as +2. And then we have perchlorate. Now the one that we memorize is chlorate as ClO3. So what does perchlorate mean? That means we add an oxygen. And remember, we leave the charge the same. And we're going to need 2 of those to get this to be a proper formula. So the formula is going to be CaClO4 2. And we're just going to keep doing the same thing, okay, for the next 3. We got calcium, which we learned from the previous problem is +2, and we have a periodate. Well, chlorate is ClO3, so iodate is IO3, and periodate is going to be IO4. Basically, we're just substituting out that halogen. And it's going to work exactly the same way, except instead of a Cl, I have an I. We substituted out the halogen. Number 3 is iron 3 hypochlorite. Now we got to go back into some of those levels that we learned already. What does the Roman numeral mean? It actually means the positive charge on the D block ion, because if we look up iron on our table here, it doesn't follow a pattern. So the D block ions, okay, they can have multiple charges, and it's always going to be dictated by a Roman numeral or an ic or an OUS ending, okay? So the iron's a +3. Well, what is a hypochlorite? Well, remember, chlorate is ClO3, chlorite is going to be ClO2, hypochlorite is going to be ClO. And we're going to need 3 of the -1 charges to cancel out 1 of the +3s. So its formula is going to be Fe ClO in parentheses 3 times. And lastly, we have ferric bromite, okay? Now ferric, we gotta go back, we gotta remember, that's one that we've memorized. You know, what is the charge on ferric? It is Fe3+. So we can call this Fe3+, we can call it iron Roman numeral 3 or ferric. That's an old lesson. But how about the bromite? That's this lesson, okay? Well, chlorate is ClO3, bromate is BrO3, so bromite is going to be BrO2. And we will need a whole bunch of those guys. We need 3 of the -1s to cancel out 1 of the +3s, so the formula is going to be Fe BrO2 3 times. So that's how you handle these prefixes of per or hypo, or the suffix changing from ate to ite, okay? Now that's all dealing with the change of oxygens. Now we're going to talk about the change with hydrogens, and we only add hydrogens. Now when we add hydrogens, we have to recognize that hydrogen has a +1 charge. So the charge is going to change when we add these hydrogens, okay? It does not change with the oxygens, but it does change with the hydrogens, okay? So when we add the hydrogens, it can only be done with polyatomic ions that have a charge, a negative charge of more than 1. It will reduce the charge by 1 because of the +1 of the hydrogen, and then a prefix of hydrogen or bi will be added to the polyatomic ion. So I got a couple examples here that I've already laid out, okay? So if carbonate is CO3, -2, and we add a hydrogen to it, well, that's going to take the charge from -2 down to -1 when that hydrogen has been added, because the hydrogen ion has a charge of +1. So that +1 with the -2 will make this new ion, HCO3, a -1 charge. And we call that new ion hydrogen carbonate, or simply bicarbonate. And the same thing happens with these other ones, okay? For example, sulfate, which is SO4 with a -2 charge, if we add a hydrogen in there, the charge is going to take the -1, and we call this hydrogen sulfate or bisulfate. And likewise, if we do that with phosphate, okay, PO4 with a -3 charge, if we add one hydrogen, it's now -2, okay? And we'll call that biphosphate or hydrogen phosphate. And for something that's -3, we could actually add 2 hydrogens. Now, if we do that, we're going to call it dihydrogen. Here are both the hydrogens, each a +1 charge. Added to the -3 will give you a -1. We call that dihydrogen phosphate. Okay, so we will always still end up with some type of negative ion when we add these hydrogens, because we only do that to things that have a charge of -1 or greater. Okay, so let's kind of do one of these problems here at the bottom. Okay, so we got magnesium and it says hydrogen carbonate. Okay, so remember, hydrogen carbonate is going to be this HCO3 with a negative charge. And then we're going to combine that with the magnesium, which is a +2. So if magnesium is a +2, we're going to need 2 of what we call these hydrogen carbonates or these bicarbonates, okay? So the formula will come out to be Mg and then it's HCO3, and we're doing that 2 times. So basically by adding these hydrogens, we're just creating a new polyatomic ion from the ones that we've already memorized to make these new polyatomic ions. And we just repeat that stuff. So aluminum is a +3. And I get that from right here. And now we have a bisulfate. Well, sulfate is SO4, so if we add a hydrogen to it, HSO4 is no longer going to be -2, it's going to be -1. So we will need a whole bunch of those guys to cancel out the +3 charge of aluminum. So it's going to be Al and then in parentheses HSO4 3 times. Now we got lithium hydrogen phosphate. Lithium hydrogen phosphate. Hydrogen phosphate is the polyatomic ion. We're not just doing phosphate, we're doing hydrogen phosphate. So phosphate's PO4, so hydrogen phosphate is going to be HPO4, and that -3 charge, when we add the hydrogen, will go down to -2. And with the lithium, which is a +1, okay, we're going to need 2 lithiums to make that work out. So lithium 2 times with the HPO4, and I am not putting that in parentheses because I only used it 1 time, as we did in our last level when we learned about that. Okay, now we got lithium dihydrogen phosphate, so we're going to add 2 hydrogens to the phosphate, so that's going to be H2PO4, and now that's going to take the charge from -3 all the way down to -1 because we've added 2 hydrogens. And with a lithium, well, that just works out in a 1-to-1 ratio. So it's LiH2PO4. But H2PO4 is the negative ion in lithium dihydrogen phosphate. And of course, if we wanted to work this in reverse, okay, we're going to do the same logic here. And the hardest part is kind of like identifying the negative ion. Obviously, this is barium. But what is this negative ion? It's ClO2. I know that ClO3 is chlorate, but this is ClO2. It has 1 less oxygen, so we're going to call that chlorite. The next one is barium again, so that part's pretty easy. And we got BrO2. Well, this is just a substitution of the halogen. So if ClO2 is chlorite, then BrO2 is going to be bromite. The next one is going to be, here's my positive ion, it's going to be sodium. But my negative ion is the HCO3. Now, I could call this hydrogen carbonate, or I can call it just bicarbonate. It's up to you. So we'll make it the long way. We'll go with the hydrogen carbonate for this problem. The next problem has potassium. And then what is FO4? Okay, well, ClO3 is chlorate, so FO3 is fluorate, and FO4 has an extra oxygen, so that's going to be a perfluorate. And lastly, we got this one. We got rubidium. And then we got to identify what is IO. Well, once again, the one that we memorize is chlorate, ClO3. So IO3 is iodate. IO2 is iodite. IO is going to be hypoiodite. And if some of this confused you, you can always reference kind of like this chart here where we have IO right here, so it would be hypoiodite. So this chart can really help out if you're struggling with this, but you really just got to kind of have this where it says putting it all together. You got to understand how we increase and decrease oxygens, okay? Remember, that changes the prefix or suffix. The charge stays the same. Of course, if we add a hydrogen, okay, the charge will change, and then you're going to call it like a hydrogen carbonate or a bicarbonate if you're dealing with the carbonate ion. So I hope that was helpful, okay? I believe this stuff does require a little bit of time and a little bit of effort, so please do the homework and do it until you have it mastered, and then when you have it mastered, move on to level 4, okay? Have a great day.